Hello, everyone, and welcome to Cisco Unplugged. I'm Dan Clamert, leader of the Wireless Center of Excellence here at Cisco. And this week, in episode 14 of Unplugged, we're going to be discussing wireless technologies for the Internet of Things, or IoT. So I would like to welcome to the show today our special guest, John Helm from Lincoln, Nebraska. Hey, John, how are you doing? Welcome.
Hey, thanks for having me today.
Yeah, great to have you here. Thanks. And then also, I'd like to welcome back Ian Procyk from Vancouver, Canada.
Hey,
Welcome, Ian.
Dan.
How are you?
Really good. Thanks for having us on.
Yep. Thanks for being here. All right, before we get started, just a couple of housekeeping items here. If you have questions, we use Slido. So if you've joined us via the WebEx panel or WebEx, you can see the Slido panel on the right, I should say. You can submit your questions there. We do have people standing by live to answer those questions during the show. If you're watching us via YouTube, you'll be able to click the Slido link below the video, and the password is there as well. And you can jump into the Slido. And like I said, we have people here standing by ready to answer any questions you've got. And if time permits, we may interject some of those questions live during the show as well. So as usual, the show is being recorded and it's available on our YouTube channel at youtube.com/@symbolgetunplugged. Also, you can register for upcoming episodes and see our list of upcoming shows at cs.co/getunplugged. And just a reminder, if you're watching or you want to be notified when we do go live and when we do post new content on YouTube, click subscribe so you're notified out there when we do post new content. All right. And now on with the show. John, take it away.
Great. Thank you, Dan. Today we're going to talk about our myriad of IoT technologies within Cisco. So we actually have quite a few other wireless IoT capabilities that cross a number of business units within the company. And today our discussion is going to be fairly high level. We're going to try and touch on a lot of technologies in a short amount of time. And do know that we have, for instance, future unplug sessions where we'll have a bit more of a deep dive into some of the various technologies. So hopefully this is a very good overview and you find it to be a helpful resource. So really, as we start this out, I want to talk about, what we use wireless for, because really there's such a wide range of potential applications that we need connectivity for. And that connectivity could be in the form of a fixed point-to-point or point-to-multi-point, mesh, mobile applications. It's really quite wide-ranging. And the bandwidth requirements are really also quite ranging, depending on if you are trying to do, say, low data rate and maybe slow response or high latency versus high data rate and low latency. As you can see in the chart here, we have examples of, for instance, in manufacturing, we have low data rates and a high latency because we're doing, say, scanning transactions for inventory purposes or various types of machine connectivity. Now, also in that type of environment, we have automated guided vehicles, AGVs, and those need constant on connection. So they also have a low bandwidth requirement, but they have a low latency requirement so that they can get faster updates and stay connected throughout the plant. Going further over to the right, we see high bandwidth requirements and low latency. So we start getting into high definition video, where we're going to gobble up that bandwidth. And that's going to be a very different technology and technology requirement, of course, than, say, those manufacturing and AGV use cases. And then we have everything in between. So as we talk about the variety of wireless technologies, and we go into our next graphic here, this is just an illustration of our many different unlicensed technologies that we support in the IoT wireless capabilities within Cisco. Now, some of these might be non-Cisco solutions. There's a little graphic at the bottom that indicates that anything with a white bar is non-Cisco, and green bar is a Cisco solution, and blue is a Cisco partner. And then we also have Cisco ultra reliable wireless backhaul that's highlighted in the dash. Now you can see in this graphic that there's quite a few different types of wireless technologies that support IoT. Not one fits all. Now many may complement each other, and in many cases we have integration with multiple wireless capabilities into a singular platform within Cisco. And that's so that we can accomplish, say, Wi-Fi and BLE, for instance, or Wi-Fi and we have 802.15.4 in WirelessHart or ISO 100 and some other access points. So we're trying to address many market segments with focused requirements for your business. So if we look towards the future and where we're at today, we have quite a diverse industrial IoT portfolio of wired and wireless and management capabilities. And so we've announced some recent product additions into this as we update our portfolio for your needs. Here in the middle, where we're focused on wireless and mobility today, we have some new additions with the 9165 and the 9167i, and my friend Ian is going to touch base on those here in a little bit as well. Now, this leads into the broader portfolio of IoT capabilities in our next graphic that really shows it's quite diverse, right? We have a lot of product for a lot of use cases. So we're not just one size fits all or make it work. We're not going to make you put a square peg into a round hole, so to speak. And so you can see that not only do we have complete product and enclosures ready to go for all sorts of environments, we also have the ability to do embedded radio systems. So you could even just put this into your own desired form factor. And so that really does open up the capability for you to make it work in your particular environment. Now, this covers a wide gambit, wide range of radio technologies. So when we look at the chart here, we can see that each of these radio technologies are supported within Cisco. We do have technologies that support, for instance, 5G and private 5G. Now, we're not the radio component to that, but we do have a lot of equipment on the backside of that, and Ian's going to talk about that in a little bit. Wi-Fi, the Cisco ultra reliable wireless backhaul, which uses essentially Wi-Fi chipsets. We're in the same spectrum, but it's a very efficient and proprietary capability, and we'll address that in a bit. RF mesh. So we actually have, 1, 2, 3 wireless meshing capabilities that I can think of off the top of my head. And so really, when we say mesh, that may mean one thing to one person, but could mean another thing to another person or group entirely. So we wanted to call that out to help you differentiate between them. And so another thing if we're going to call out some important facts, looking at this next graphic, I want you to all be aware of that we have a number of validated designs that are already in place. Now, a validated design within Cisco it's a very high performance, high importance. We put a lot of effort into that. We set up the entire network that is in the validated design. We test it. We verify that everything is going to function. It really becomes an as-built document for you to follow. And we cover a lot of different types of environments with our validated designs, from manufacturing, oil and gas, transportation, so many use cases for you to reference. And these are all available for our customers and partners at Cisco.com. And we do want you to reference those to help you succeed. So I'm a little bit of a fast talker because I've had lots of coffee today, and I'm going to go ahead and pass this over to Ian. Ian, take it.
Yeah, for sure, John. Well, I'm equally fast, if not faster. And I survive on caffeine. So we'll see how it goes here. So kind of following on John's layout on the table there, we're going to break this down into the different sections as we go through them. And again, we're going to have some follow-up episodes on this. In fact, episode 15, the one coming up right after this in 2 weeks' time, Dan Davis and Ray Guy are going to give us an update on a deep dive on URWB, right? Ultra Reliable Wireless Backhaul. So stay tuned for that. So the first one up is around 5G and private 5G. And if you've been paying attention to any of the glossies, this is grabbing, you know, all the CIO attention over the last few years. And this is a big topic. Cisco's entrance into this space is really around the lightly licensed spectrum, the CBRS spectrum in the US. And there were some announcements made at Mobile World Congress last year as it relates to private 5G with our two managed service partners. So this is a network as a service offering. It's a little different than your typical WLC or, you know, dashboard kind of experience here. This is a end-to-end solution delivered from us and our partners, and I'll get into that in a minute. So at a super high level, you know, this is what we're working with here. So if you look at the graphic, you'll see that we're providing SIM cards all the way through to integration with authentication and back end. This system, like any typical 5G deployment, requires precision timing on the switching infrastructure. So you need to have switches that are 1588 capable that can do precision time protocol. So there's maybe some changes in the infrastructure required for that. And again, we're providing the core. So when you kind of take a step back and you look at who does what here, Cisco is typically involved in providing the core switching infrastructure, whether that's on-prem or in the cloud. The SIM cards are provided by us as well. Our partners, typically Logicalis or NTT, depending on where you are in the world, are involved in the RF planning and design of the solution and the first level of support as it relates to, you know, on-site coverage mapping and all that kind of stuff, billing, etc. And then as the end customer, like I said before, this is a subscription service, and it's important to note that this really runs in spectrum that is dedicated. So maybe to take a step back and think about, well, where would I use private 5G? And this is really an application or a solution in places where you need wide area coverage. You need perhaps super reliable connectivity in spectrum that's protected. Whereas, you know, obviously we're not going to get the same level of assurance in unlicensed ISM band in 2.4 or 5 and at some point in the future 6 gigs. So both countries, Canada and the US here, have both set forward some rules and regulations as it relates to operations in this spectrum. The requirements to check into basically a government database through an operator, an AFC operator, or SaaS operator that allows your network permission to operate in an area. And it's important to note that we're not talking here about hundreds of megahertz of spectrum or gigahertz of spectrum in the case now of 6 gigs. We're talking about channels that are typically 10 and 20 megs wide in an area. So you have to calibrate your thinking to the use case here as well. We're not going to be driving gigabits per second over a CBRS solution, but this is going to be providing robust connectivity to robotics, to AGVs, to things like that in warehousing and industrial operations is where we're seeing a lot of the use cases come from in this solution. On to our next subject, which is ultra reliable wireless backhaul. And now this may be a new term for some of you. If you've been following the trade mags over the last few years, a few years ago, Cisco acquired a company known as Fluid Mesh, and that's where this solution came from. Now, as John mentioned, URWB is actually using a Wi-Fi chipset, right? A standard off-the-shelf Wi-Fi chipset, but the MAC layer is not the same. So we're not using the standard 802.11 MAC to deliver the connectivity. And the reason for that is really around the fact that this architecture is designed for point-to-point, point-to-multipoint, and on the right-hand side, as you can see, solutions that require, you know, high-speed mobility. And so when you take a step back and you look at the actual implications of that, we're able to drive a roaming up here to, you know, 360 kilometers an hour, 220 miles an hour, which is substantial. You can't do that in Wi-Fi with pedestrian level design, right? It's the way Wi-Fi has always been designed is walking speeds, right, or slow moving assets. And so this is a technology that's great for when we need to do handoff at high speeds between, you know, kind of make before break roaming. It's also good for longer range connectivity. So historically, the solution set here has involved higher gain dishes for those point-to-point shots. I'm showing you a picture here on the left-hand side of a deployment I did in testing this product out not too long ago. This is actually operating on a link. We were testing it, 10 plus kilometers in this application. Should mention I'm from Vancouver, so the metric system is what I'm working in most of the time here. And I guess the question would be, well, where would I use this solution versus, say, for example, Wi-Fi or P5G? And this is now unlicensed spectrum, so anybody can turn this up and run this around the world. That's a certainty. And also you'll find that typically this is going to fall under slightly less expensive, right? P5G and licensed spectrum solutions are going to be a little bit more expensive. You get what you pay for in robustness, though. How you manage this is kind of cool, right? You can actually manage this standalone, like a good old school autonomous bridge, like we had in the years gone by in iOS. So if you've got, used to the old 1410s or those style of AP, or if you point-to-point link, that can be done. But you can also manage this via the IT operations dashboard, which allows us to centralize management under kind of one umbrella for these different assets here we've brought into this solution. A lot more on this as we move forward in the next episode. Now, it is important to note that the hardware in this portfolio has also changed a little bit over the last few years as we've moved kind of into a centralized engineering model where our teams are working towards common hardware between our Wi-Fi solutions and URWB. There are some exceptions, and I've highlighted them here in yellow. So if you look at for example, the far left-hand side, the small guy, the 9165E, there's actually a picture right there on top of a Roomba from Cisco Live that I grabbed. That's pretty small, right? And it's really designed to be a client in a network. So it can actually operate as something called a workgroup bridge, which I'll get into in a few minutes, or it can actually operate as a URWB endpoint. The 9165D, great for point-to-point solutions where you're doing an integrated shot between two locations. And then you can see as we move up a little bit further here, we have the 9167 and the 9167E. And the 67E I actually have sitting beside me. Maybe we'll pull up a full screen of me here, Tom. This is what the 9165 looks like on the side. And basically the 9167 is essentially a full-featured AP that can actually be operated in both CURWB mode, Wi-Fi workgroup bridge mode, controller mode, etc. So you can have this thing, do multiple different activities. It's mutually exclusive, one at a time. You can't do, dual on this radio at the same time. So this is going to be a CURWB endpoint. It'll be a Wi-Fi AP or a workgroup bridge client. Okay, so that brings us to the next section here, which is, stepping into some of the Wi-Fi. And, I'm showing a mesh diagram here. When I talk about Wi-Fi, I really mean, anything that speaks 802.11. But I thought this would allow us to paint a picture of the entire kind of solution here and pick this apart. So Wi-Fi mesh is great because it shows us the ability to use an access point as point-to-point bridge, which is what you see in the middle there, the backhaul connectivity. But we can also provide client access, which is different than CURWB. CURWB is not a client access technology. You can't associate to an AP that's in CURWB mode. It's meant to be a backhaul technology between two CURWB radios. So I can't take an 802.11 device, a laptop or an iPhone, Android, and connect it into CURWB, but I can into a mesh radio. So in mesh, we have this concept of a root node, a mesh AP mode where there's the other end of the link. And then I can break that out into client access on both 2.4 and 5 gigs at the same time. I can do an Ethernet connectivity off of this, like downstream switches you see here. I've highlighted in yellow my favorite topic, which is workgroup bridge. And I keep mentioning this because it's an interesting little Swiss Army knife for us. Workgroup bridge is basically one of our radios operating as an 802.11 client doing MAC cloning. So we can actually have layer 2 connectivity with multiple VLANs across a link to a WGB. So that WGB can have, as you see here, a single client, or it could actually have a little switch behind it with up to 16 MACs behind. And so the workgroup bridge is really cool for those types of applications where you need a Wi-Fi device to connect to a Wi-Fi network and provide a wireless to wired bridging application. The other kind of cool part about a lot of these APs operating in mesh mode is that you can do PoE out on them. And PoE out, as you see on the bottom, can power things like surveillance cameras or the Apollo camera, as you see here in this picture. So some pictures of this, spot the workgroup bridge. On the left-hand side, one of the customers I work with here deployed some video conferencing solutions, but found the wireless to be a little lacking and challenged in classrooms. And so they repurposed some of their old 3702s. You see them sitting on the shelf there. Those 3702Is are operating in autonomous mode. They're actually operating as a worker bridge client, and they're providing the robust connectivity as they wheel these things around between classrooms. On the right-hand side, John's very familiar with this topic as well. This is a haul truck. Again, you can't see the work group bridge in this picture, but you can see its antennas. And if you go to the next picture here, you'll see the in the box behind the cab of the driver is the actual work group bridge, along with one of our IP67 rated Ethernet switches as well. So that whole thing is in that enclosure. And it's actually what's, in this particular case, providing connectivity to that truck when it's being operated in an autonomous mode, right? So this massive asset driving down the road connected to the rest of the world via autonomous. Kind of cool. Now, we talked a little bit earlier about this other mesh, you know, that might confuse folks, especially if you have folks that are in your organization that are involved in the OT side of things, especially in utility companies. Resilient mesh or YSUN is often what you're going to see. This is a picture from just down the road at of my house. This particular asset here is mounted on a pole. It's one of our pole top routers. It's a connected grid router. And there's a picture of what it looks like inside. And the purpose of this mesh, not to provide connectivity to residents. This is very low bit rate. It's operating around an 802.15 protocol, IPv6. But it's providing connectivity to smart meters, right? So the kind of meter that's on the side of your house for metering of your hydroelectric utility or different other types of utilities. And also in some cases, distribution automation. So reclosers, other things that need to be monitored and controlled remotely can be connected over this asset. And there's multiple uplinks available. You have a 900 meg radio that's downstream facing those meters, but you might have a cellular radio or a WiMAX radio inside, depending on the generation and deployment here. This particular example is a cellular example and a WiMAX example. So a super high-level overview of that architecture. I'm not going to get into the specifics here, but this is a massive scale kind of system. This is meant for millions of nodes. As you can imagine, in a large province or state, you're going to have lots of metering applications. I think we're over 2 or 3 million IPv6 endpoints now in the mesh network here in my province, which is where BC Hydro is operating. One of the first customers to deploy this globally. Now, the last segment here in my section is around something called LoRaWAN, a long-range alliance wide area network. Now, LoRaWAN is an interesting technology. This moves a little bit outside of IP connectivity. So this is not a solution to provide wide area coverage like something on, you know, private 5G or maybe CURWB. This is really about connecting sensors. Now, typically outdoor sensors that are battery powered. That's generally where this plays. And this is a 900 megahertz technology, so we're sub 1 gigahertz, which means we have lots of propagation advantages down here. And the range is pretty substantial. You can get ranges, you know, easily into the 8 to 10 kilometers here out of the box over kind of flat terrain. Not a problem. You start putting assets up higher on mountaintops and whatnot, you can actually get some pretty creative distances. So I did some testing on this several years ago. Again, most of my stuff is done in the middle of the night because this is when you can get up towers and install things. This is one of our sites we maintain. So I put a little small Yagi on this to actually see what would happen for distances on one of the ports. And I did some driving around my city here. This is the city of Vancouver, just north of the border. You can actually see the Washington, BC border at the bottom in the picture. And you know, I did the first test I went through the drive-through on the way back from this installation. The day after I went through there, this is like 12 miles away. And that little device that I'm holding next to the mirror is a little test box. You can actually push the button on there, and it sends basically a command, a sample data packet up to the gateway. And you can actually see the return and as far as how you were heard and how strong the gateway is at your location. So this little button pressed actually confirmed that I had connectivity, you know, almost non-line of sight at almost 20 kilometers in distance. End to end, this solution is all about those sensor connectivity situations, right? So tank levels, pressure levels, vibration, presence, all that kind of stuff. Anything you would want to do A to D or I/O. We're not providing IP connectivity out at the edge of the network, right? So that those sensors are not IP addressable. The communications there is too low bit rate to support that. So I think we top out around 5 kilobits per second at the absolute highest end of LoRaWAN. More typically, we're in the hundreds of bits per second. Those connections all funnel up to a gateway or multiple gateways. Those gateways can operate on up to 16 different channels, if you're using that particular one in the middle. And then you have the option of managing this through industrial asset vision, which is a dashboard we have. Or you could put the gateway into a mode where you can actually forward that traffic out to a third party like the Things network and monitor those in a third party dashboard. This is some examples of some of the cool sensors here that we're working on. So they actually released now. This AV400 sensor on the left is kind of cool. It's a A to D, basically analog to digital sensor gateway. So you can measure all sorts of analog values you're going to have in process control. 4 to 20 milliamp loop currents is a big, it's been around for, ever and ever. Or digital state, right? What's the state of some contact closures, etc. And a vibration sensor here on the right-hand side for rotating equipment, where you want to, get in front of preventative maintenance issues, where you're dealing with bearings and things like that might be starting to wear. So those two gateway options I showed you really is the IXM on the left-hand side that looks just like an access point, right? It's the same bolt pattern as our 1532 and 1562, if you're familiar with those APs over the years. This is, like I said, an 800 meg solution. Depending on where you are in the world, that might be slightly different. North America, 900 megs, 902 to 915, or 928. And on the right-hand side is a smaller insertable module for our industrial routers, right? So if you have an application where you want to put a LoRa gateway in a device that's, field asset somewhere in a cabinet, that's another particular example there. So kind of two different options for that. So I said I'd talk fast. John, I see we got the next section up here, which is around maybe more of the indoor applications, but maybe some outdoor as well, right?
Indeed, yeah. Yes, indeed. So, and thanks for that. Well done on timing too, Ian. Now we're going to talk about I think more of an influence from our enterprise product line within Cisco. So as it turns out, IoT has made its way throughout much of our product line. And when we talk about license-free technologies that apply here, probably the most proliferate is Wi-Fi. I would say probably everyone who's watching this has some sort of Wi-Fi at home or certainly at work. Well, our Catalyst series 9100 series access points actually have embedded IoT capabilities. So with the 9100 series, we have the ability to work with Cisco Spaces, with built-in BLE radios. Now with those BLE radios and the 9100 series access points, we can actually host a BLE gateway. So that can actually become the gateway for any of the endpoint devices that are trying to connect into the network. Now, what's interesting is that with those access points, there are two models that also have built-in environmental sensor capabilities. So we can detect humidity, air quality, and temperature. And so that's another interesting IoT use case directly in the platform for, say, smart building applications or HVAC and other potential use cases. So what that looks like from a high-level architecture. So on the wireless side, where endpoint devices are connecting to access points that are running the IoT gateway on a container. Those, of course, connect to our Catalyst 9800 wireless LAN controller, going out through DNA Spaces connector into the cloud where DNA Spaces is being supported. And then for partner applications, that is coming through our Firehose connector. On the wired side, very similar in connectivity. That is, we can actually run wired sensors on the network as well, going through our Cat9K switching. So as we look at what some of those sensors might look like, They cover a number of different potential use cases, and this could be from environmental monitoring, door open, close, power monitoring and conditioning, temperature, just so many other potential use cases. Wayfinding is another one, and these employee safety, space utilization. Gosh, if you were to get onto our DNA Spaces IoT marketplace, you'll see a myriad of sensors that you could look into. You could research, determine what is your best fit, and then work with those manufacturers to acquire the products that best fit your needs. Now, it turns out we have Cisco Meraki sensors that are also available, and those are they're really making a big impact with our Meraki customer base. So these will connect with our MR gateway, or our MV video solution can be a gateway for this as well, going through cloud management, and then you're able to see information from these sensors via Meraki dashboard. And you can see that it's actually a nice wide range of sensors for a lot of use cases. Moving along then with Meraki, actually the Meraki camera solution provides IoT capabilities as well. So some examples here, used in, say, manufacturing and warehousing. We can use it to manage PPE compliance and worker safety. We can look for product defects and just inventory control. And also keep in mind that there are built-in analytics within the Meraki dashboard for using this for IoT purposes. Another type of sensor technology, which is partner-led, works with our industrial wireless 6300 series HC access point. So our strategic partners here, Emerson and Honeywell, make plug-in modules that attach to the access point to support WirelessHart and ISA 100, which, by the way, are both also another type of wireless mesh technology, as each of their devices can mesh with each other to extend range and get into hard-to-reach areas. And so this does provide not only a WirelessHart and ISA 100 solution in hazardous areas, but also Wi-Fi connectivity with these access points, also supporting our wireless meshing capabilities to extend that coverage further into the plant. So I hope you've all enjoyed this high-level overview. There's a lot of information that any one of those can be a great deep dive to go into sometime. Please work with your account teams and contact us to see what product may be a very good fit for your application. And thanks again for joining us.
All right. Thank you, John. Thank you, Ian. Great session on wireless for IT. Really appreciate it. All right. I don't see any other additional questions at this point, so we're good on the questions. So as we close out, I want to just thank everyone for watching today's episode. If you have a moment to complete the survey when you exit out, we'd appreciate your feedback on the sessions. Also, a quick reminder, if you're looking for future sessions, you can hit cs.co/getunplugged to see future sessions that are available and join there, or register there, I should say, to join. Also, a reminder to join our YouTube channel, or check it out, I should say, and subscribe at youtube.com/@getunplugged. All right, until next time, thank you for tuning in, and stay connected and unplugged.